Out there, in the vast expanse of space, floats a seemingly insignificant ingredient, often overlooked in the grand tapestry of the cosmos. We call it cosmic dust, a term that belies its profound importance. These tiny particles, barely visible to the naked eye, hold the key to the universe's most spectacular creations, from the smallest grains to the grandest structures. They are the building blocks of stars, planets, and even life itself, forming the very essence of celestial bodies. Drifting silently through the cosmos, cosmic dust might appear inconsequential, yet it is anything but. But within these minute grains lies an epic story, a tale of cosmic cycles and the birth of wonders spanning billions of years. Cosmic dust is found everywhere we look in the universe, from the darkest corners to the brightest regions. It inhabits the sprawling interstellar medium, the space between stars, acting as a bridge between celestial entities. It gathers in dense clouds, creating breathtaking nebulae, the nurseries of new stars, and it plays a crucial role in some of the most energetic events in the cosmos, like the explosive deaths of stars known as supernovae. Understanding cosmic dust is about more than just studying tiny particles. It's about unlocking the secrets of the universe. It's about unraveling the very fabric of the universe and our place within it, connecting us to the stars and beyond. Where does this cosmic dust come from? These minute particles that birth stars and planets? The answer lies in the fiery demise of stars much more massive than our Sun. These stars, in their final act, go supernova. They erupt in a cataclysmic explosion, spewing out the elements forged in their core. These stellar explosions are the universe's grand recycling plants. Among the scattered remnants are elements like carbon, oxygen, silicon, and iron. These elements, essential for life as we know it, were cooked in the heart of a dying star. As the supernova's fury subsides, these elements cool and condense. They form tiny grains of dust, each one a testament to the life and death of a star. Cosmic dust, born from the death of stars, doesn't simply drift aimlessly through space. It gathers, drawn together by a force both subtle and powerful, gravity. Over eons, these dust particles clump together, forming vast swirling clouds known as nebulae. These nebulae, often spanning light years across, are the nurseries of stars. Within these dense clouds of cosmic dust and gas, a magical transformation begins. Gravity, the architect of the cosmos, continues to draw the particles closer. The nebula contracts, its core growing denser and hotter. This process, spanning millions of years, sets the stage for the birth of a star. The cosmic dust, once scattered remnants of a supernova, is now poised to become the building blocks of a new generation of stars. Deep within the heart of a nebula, gravity orchestrates a delicate dance. As the cloud contracts, it begins to spin. The spin, initially slow and almost imperceptible, gradually gains momentum. The cloud flattens, taking on the shape of a rotating disk. This swirling disk, a cosmic ballet of dust and gas, is the precursor to a star system. At the heart of this swirling disk, the core continues to collapse under its own weight. The temperature and pressure soar, fueled by the relentless crush of gravity. The core, once a diffuse collection of dust particles, transforms into a dense, hot ball of gas. This is a protostar, the embryonic stage of a star on the verge of ignition. Section 5. A star is born, ignition, and the dawn of a new sun. This is the story of how a star comes to life, a tale of cosmic birth and transformation. The protostar, bathed in the soft glow of its own heat, is not yet a true star. It is a celestial body in the making, a promise of the brilliance to come. It lacks the nuclear fusion that powers the stars and illuminates the cosmos. Without this fusion, it remains a mere shadow of what it is destined to become. But deep within its core, a critical threshold is about to be crossed. The conditions are aligning perfectly for a monumental change. The temperature and pressure become so intense that hydrogen atoms, the simplest and most abundant element in the universe, are forced to fuse. This is the moment of ignition. This fusion reaction, the merging of hydrogen atoms to form helium, releases an incredible amount of energy. It is a process that will sustain the star for millions, if not billions of years. This energy in the form of light and heat radiates outward from the core. It is the lifeblood of the star, the force that will drive its brilliance. The protostar, once a dim ember in the cosmic darkness, erupts into a brilliant star. It is a moment of transformation, a birth witnessed by the universe. The light from this newborn star illuminates the surrounding nebula, casting intricate shadows and revealing the majestic beauty of the dust clouds that gave it birth. This is the dawn of a new sun, a beacon of light in the vast expanse of space. Section 6. Protoplanetary disks, the whirlpools of creation. While the star ignites at the center, the remaining dust and gas in the disk continue their celestial dance. This disk, known as a protoplanetary disk, is where planets will eventually form. Within this swirling disk, tiny dust grains, remnants of the original nebula, collide and stick together. These collisions, initially gentle and infrequent, become more frequent and energetic as the particles grow. Over millions of years, these dust grains coalesce into larger and larger clumps. These clumps, drawn together by gravity, sweep up more and more material, clearing paths in the protoplanetary disk. These are the seeds of planets, gradually accumulating mass and taking shape within the protoplanetary disk. Section 7. From dust grains to planets, a story of accretion. The process of planet formation, from tiny dust grains to celestial bodies, is a testament to the power of time and gravity. As these planetary embryos orbit the central star, they continue to attract and accumulate material from the protoplanetary disk. This process, known as accretion, is a slow and steady accumulation of mass. Over millions of years, these planetesimals, as they're now called, grow larger and larger. Their gravitational pull intensifies, attracting more material and clearing their orbital paths. Some planetesimals collide and merge, creating even larger bodies. The protoplanetary disk, once a chaotic swirl of dust and gas, gradually transforms into a more ordered system of planets orbiting a central star. Section 8. Cosmic Dust. A universe connected. Cosmic dust, often overlooked in the vastness of space, is the thread that connects everything in the universe. It is the legacy of dead stars, the building blocks of new stars, and the material from which planets, and ultimately life itself, emerged. The very atoms in our bodies, the iron in our blood, the calcium in our bones, were once forged in the heart of a star and scattered across the cosmos in a supernova explosion. We are, in a very real sense, stardust. The universe is not a collection of isolated objects, but an interconnected web of matter and energy, constantly evolving and transforming. Cosmic dust is a tangible reminder of this interconnectedness, a testament to the grand cycle of cosmic birth, death, and rebirth. Section 9. We are stardust, the profound connection to life. The story of cosmic dust is not just a tale of distant stars and galaxies. It is a narrative that intertwines with our very existence, connecting us to the cosmos in ways we are only beginning to understand. It is a story about us, about our origins and our place in the universe. The elements that make up our bodies, the very building blocks of life, were created in the hearts of stars and dispersed throughout the universe by supernovae. These cosmic events are not just distant occurrences. They are the reason we exist. Every atom in our bodies has a cosmic history, a journey that began billions of years ago in the fiery furnace of a star. This journey is a testament to the interconnectedness of all things. As we gaze up at the night sky, we are looking at our own origins. The stars are not just distant points of light, they are our ancestors. The iron in our blood, the oxygen we breathe, the very essence of our being, the carbon that forms the basis of all life on Earth, all were created in the hearts of stars. These elements are the building blocks of life, forged in the crucibles of stellar furnaces. We are stardust, and the universe flows through us. This profound connection to the cosmos reminds us that we are part of something much larger, something truly magnificent. Section 10. A legacy in the stars. The story of cosmic dust is a story without end. It is a continuous cycle of creation and destruction, of death and rebirth. As stars die, they enrich the interstellar medium with the elements that will form new stars, planets, and perhaps even life. And so the cycle continues, with each generation of stars adding to the rich tapestry of the cosmos. The next time you look up at the night sky, take a moment to appreciate the silent beauty of cosmic dust. It is a reminder of our connection to the cosmos, a legacy written in the stars. We are part of something vast and ancient, a universe teeming with wonder and possibility. And it all began with a speck of dust.